This is Venkat sir, the physics. Okay, so today we are going to discuss the topic is parallelogram of a vector. Means addition of vector. One application we are going to discuss. We have different types of addition of vectors there. That is the polygon law of vector, triangle law of vector, and parallelogram of a vector. Okay, so today we are going to discuss a parallelogram of a vector. Okay, so definition we can see here: if the two vectors are represented in magnitude and direction by the adjacent sides of parallelogram drawn from a point, the diagonal passing through the point represent their resultant both in magnitude and direction. Okay. See, we can take the two non-zero vectors. Okay. We can take the two non-zero vectors. This is one vector. I'm taking the name is we can take p vectors. Okay. And one more vector adjacent. You can draw adjacent side of adjacent side. So this is a we can give the name q vector. Okay. Now these two vectors are mutually inclined, so the angle is theta. Okay. Then we can draw the parallelogram. The opposite sides are equal. Then we can draw this parallelogram. Okay. Now these are the it will become like a parallel. Opposite sides are equal. Then we can write it here p vector and this is a q vector. Okay. So now as per the definition, the diagonal passing to the point where the p and q vectors are intersect. Okay. From that point, we can draw the diagonal. That this diagonal represent the resultant vector and magnitude. Okay. This resultant vector with the p vector making angle you can consider that is a alpha, and with the q vector suppose angle is a beta. Okay. Now, so from this equation, so we know the right angle, what you call triangle law, the addition of vector. If the two vectors you can take in a triangle, two vectors in one direction, one order, and one vector is in reverse order, then we can write a vector and b vector. The resultant vector is r. So then we can write it from this diagram r equal to a plus b, resultant vector equal to a vector plus b vector, we can write it. Same thing here, resultant vector, what we can write r equal to p plus q. Okay, but I want the resultant magnitude. Resultant magnitude when we'll take when the right angle triangle. So we need the 90 degrees. Okay, then what I am doing here, extend the p vector and draw the one perpendicular. Okay, now this angle is 90 degrees. Okay, then I'm giving the names here a vector, sorry, A, B, C, D, E, right? So these are points A, B, C, D, E. Here AB equal to CD and AD equal to BC. So means the opposite sides are equal. Okay, that is the parallelogram is done, right? Then we need to find the resultant magnitude. To find the resultant magnitude, we need the DE distances. It means this vector, how much is it that we need to find, as well as C and E. Okay, so by using the trigonometry ratios, we can find it. This is an angle. This is an angle between P and Q vectors. How much is that? This angle also same. Why? Because these two Q vectors are parallel and the this vector is a parallel to the P. Okay, so angle is the same. Now from triangle, we can take CDE, triangle CDE. Okay, so from this equation, we can write the trigonometry ratios. That is the cos theta equal to what we can write here, base by perpendicular. Sorry, base by hypotenuse. Okay. Then what is the base here? You can take the C angle is theta. The opposite one C is a perpendicular, and with the making angle with the hypotenuse, that is the adjacent side. Means it is a base. Okay. So from this equation, we can write dE by dC. dE by dC. Okay. Then here dC represents what? That is a q vector. So dE by q vector. Right. So from this equation, cos theta equal to, we can write dE by Q. Then dE equal to what we can write? Q into cos theta. So means how now we got this one Q cos theta. right? Same thing similarly, we can find the, by using the sine theta, we can find the perpendicular component. So sine theta equal what? Perpendicular by hypotenuse. Okay. So what is the perpendicular here? C, opposite to the angle, that is the C is what? Perpendicular, right? So we can write CE by hypotenuse is a DC. Okay. So then sine theta equal to CE, we know we need to find, right? DC value is how much here? DC vector is what here? Q. Okay. Then C equal to, we can write Q into sine theta. Okay. Now it is the perpendicular component also came, Q sine theta. Right? Now, so here by using the Pythagoras theorem, or simply we can consider from the triangle. From which triangle we can take here? So, and triangle ACE, from triangle ACE. Okay. From triangle ACE, we can write it. So, what we can write here, by using the Pythagoras theorem or triangle law, we can find the vector, what you call resultant magnitude of vector. Then, we can write this is a OC equal to, by using the Pythagoras theorem, we can write AC square equal to, one more side is what? AE equal to AE square, and perpendicular is what? CE square. Right? Okay. Now, continuation. Here we know the AC is what and OE is what, CE is what, everything we know. So from this equation, AC is what? Resultant vector, that is the R, right? So R square equal to AE. AE means what beta here? AD plus DE. Okay? AD plus DE whole square plus CE square. Right? Then AD, what is the vector here? P vector. So we can substitute R square equal to, this is AD vectors. We can represent the vector form. Okay. Then AD is what? Here P vector plus D what? Q cos theta. Q cos theta whole square plus CE is what? Q sin theta. Q sin theta whole square. Right? Okay. Then, so here we know this is a form of like a, which form this one? This is a plus b whole square formula. So we know the a plus b whole square formula. What is a plus b whole square formula? A square plus b square plus 2ab. Okay. Then same simplify. R square equal to p square plus q cos theta square plus 2pq cos theta. Right? Then what is this one? Q q q sine theta whole square. Okay. So from this equation, we can add the one more step. R square equal to p square plus q square cos square theta plus 2pq 2pq cos theta plus q square sine square theta. Right? Okay. So now here anything is common is there. So here you can see a q square cos square theta and q square sin square theta. So here q is a common is there. Okay. Q is a common. Then we can write r square equal to p square plus q square. I'm taking the common. Then cos square theta plus sin square theta plus, so what is the remaining term? 2pq cos theta. Okay. So now we know the mathematical trigonometry identity, that is a cos square theta plus sin square theta equal to 1. Okay. Then you can substitute here resultant r square equal to p square plus q square plus 2pq cos theta. Okay. So this is what resultant magnitude for r equal to v1. Then you can write the formula is p square plus q square plus 2pq cos theta. Okay. This is the resultant magnitude of a vector. What is this one? Resultant magnitude of a vector. So now we did the resultant magnitude. Means resultant magnitude is done. Then direction of the resultant. Direction of the resultant vector. Okay. So next one, this is the resultant magnitude. Then we can write direction of the resultant. Okay. So now we can find the direction of the result. So just I'm going back to the diagram. You can see here. Okay. So here with a p vector resultant making how much angle? That is the alpha. Okay. So we know the alpha. This angle is alpha. We can find the direction. Direction means which trigonometry ratio we can use? That is the tan theta, right? Tan theta equal to what? Opposite by perpendicular base. Means a perpendicular component by base component. Okay. So here what is the perpendicular? C base is what? AE. Okay. From this one we can write it the what we call the direction of vector. So from the diagram, I'm writing the angle. The suppose resultant vector resultant vector making angle with the p vector is alpha. Then we can write tan alpha equal to what is the tan alpha from this diagram? Tell me. Tan alpha equal to C by AE. C by AE. Okay. Tan alpha equal to CE by AE. Okay. So now CE means what? Opposite side. That is the A sine theta, and AE means what? P plus Q cos theta. I'm writing directly. Okay. That CE is what? B sine theta by A is what? A plus A vector plus A vector plus this is a capital A vector plus B cos theta. Okay. So from this equation alpha equal to we can write it that is the tan inverse of B sine theta by A plus B cos theta. Okay. So we are considering the one angle with the alpha, then we will get the means a p vector with a resultant vector alpha, then what we get? That is a b sine theta by sorry, actually we taken the pq, right? Okay, sorry. So we can write this one is a okay. So this is a q sine theta by p plus q cos theta. Okay. Then alpha equal to tan inverse of q sine theta by p plus q cos theta. Okay, this is the direction of vector. Okay. Thank you, everyone.